Okay, so now we are looking at part 10, number 1. So part 10, we're dealing with reaction stoichiometry to start it out. We're going to look at mole ratios. So stoichiometry is the branch of chemistry dealing with the amounts of substances involved in chemical reactions. It's why we've been doing everything up until this point. It's kind of all going to come together here. So reaction stoichiometry especially is calculations based off of balanced equations. Mole ratio, which is what we're going to focus on in this part, deals with the conversion factor relating molar amounts of two substances that are involved in a reaction. So basically, you're going to say something like moles of substance A to moles of substance B. In order to do this, we need to write the balanced equation, then determine the mole ratio, and then do dimensional analysis. So for number 1 here, this first example, what we're going to do is we need to basically find the mole ratio here, and we're going to use it. So for number 1 here, the first thing we need to do following those 3 steps I gave you in your notes, we need to make sure we have a balanced reaction. So I'm just going to write this reaction out. So we have NO2, we have water, and we're going to form HNO3, which is nitric acid, and NO, or nitrogen monoxide. Okay, so now we need to balance this. So looking at it, is it balanced? Well, no, I definitely see 2 hydrogens here and only 1 here. So I'm going to start there, okay? Now if I look on this side, I've got 2 nitrogens and 1 nitrogen. So 3 on this side and only 1 here. So I'm going to put a 3 here and see what that does for me. So now I've got 6 oxygens plus 1 is 7. So I've got 6 and 1 is 7. So now I'm good to go. Okay. Now I am going to take the number I'm given in the problem. So how many moles of nitric acid can be produced in the reaction of 1.8 moles of nitrogen dioxide with excess water? So we're going to start with 1.8 moles. Now, for the rest of this unit, you need to keep this label after this. Okay, that's going to be important because we're going to be changing from one substance to another. Here's where the moles ratio step comes into play. Since I have moles of NO2 here, on the bottom I want to write moles of NO2 using dimensional analysis so those can cancel. I'm trying to get from moles of NO2 into moles of nitric acid, or HNO3. HNO3, so I'm going to put that on the top. Now, I need some numbers to go right here. I need to figure out what numbers they should be. On the bottom, we'll start there. So we have NO2 down here, and I need to know how many I should put here for moles. So if I look, I'm going to look back up at the reaction here. So since there's a 3 in front of the NO2 right here, that means I'm going to put a 3, I'll put it in red here, down here. Okay, so this 3 came from the 3 that's in front of NO2 in the reaction up here. Okay, so that means if I have NO2 here and there's a 3 here, when I look at HNO3, I want to look up here, find the number, and that goes here. Okay, now if it just so happened it was water instead, there's assumed a 1 here, so that's what you would use there. So I'm going to take 1.8 times 2/3 essentially. I'm looking at 1.2 moles of HNO3. Now, this seems pretty straightforward. Hopefully, this will be part of a bigger problem as we keep working, but make sure you know how to do mole ratios at this point.